Imagine a gateway that bends space and time, a cosmic shortcut to distant galaxies or even parallel universes. Black holes and wormholes, two of the universe's most mind-bending mysteries, might just be the key. Could they be hidden doorways to the unknown? Let's dive into the science behind these cosmic enigmas. What are black holes? Black holes are cosmic monsters, regions in space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse under their own gravity, creating a point of infinite density called a singularity. Around this singularity is the event horizon, the boundary beyond which escape is impossible. Anything that crosses this threshold is lost forever, trapped in a one-way journey to the unknown. Scientists believe black holes warp spacetime itself, bending light and altering time in ways that defy common sense. Some black holes are small, formed from dying stars, while others, supermassive black holes, lurk at the centers of galaxies, including our Milky Way. The mind-bending part? According to Einstein's general relativity, time slows down near a black hole. If you could somehow hover near one, you'd see the outside universe speed up, while to an outside observer, you'd appear frozen in time. A black hole isn't just an object, it's a tear in reality itself. Black holes are born in the violent deaths of massive stars. When a star much larger than our sun reaches the end of its life, it undergoes a supernova explosion, shedding its outer layers in a massive burst of energy. What remains collapses inward, crushed under its own gravity until it forms a singularity, a point of infinite density. The surrounding space becomes so warped that not even light can escape. The size of the resulting black hole depends on the original star. Stellar black holes are a few times the mass of our sun, while supermassive black holes, millions or even billions of times larger, sit at the hearts of galaxies, feeding on matter and merging with others over billions of years. Some theories suggest that primordial black holes, much smaller and possibly created in the early universe, might still be lurking undetected. Whether born from dying stars or cosmic chaos, black holes are nature's most extreme laboratories, testing the limits of physics itself. What happens if you fall into a black hole? Falling into a black hole would be the most terrifying and mind-bending experience imaginable. As you approach, gravity gets stronger, pulling you faster and faster toward the event horizon, the point of no return. From the outside, an observer would see you slow down, appearing frozen in time as you near the edge. But for you, time would seem normal, but space itself would stretch in bizarre ways. This is called spaghettification, where the gravity at your feet is stronger than at your head, stretching your body into a long, thin strand like spaghetti. Eventually, you'd be torn apart at the atomic level. But what happens next? If black holes truly lead to singularities, your matter would be crushed into an infinitely small point. However, some theories suggest something more mysterious. You could emerge in another universe or be funneled through a wormhole. And if black holes somehow connect to white holes, objects that can only expel matter, then maybe falling in isn't the end, but a new beginning somewhere else. No one knows for sure, but one thing is certain. Crossing the event horizon is a one-way trip into the unknown. Could black holes be the key to time travel? Some physicists believe so. According to Einstein's general relativity, massive objects warp spacetime, and since black holes are the most extreme warps in existence, they could theoretically alter the flow of time. Near a black hole, time slows down drastically compared to the outside universe. If you could orbit close enough without falling in, you could experience time at a much slower rate than people back on Earth. In theory, this means you could travel to the future, a kind of time dilation that could let astronauts return after what felt like a few years to them, while centuries passed on Earth. But what about traveling to the past? That's where wormholes come in, hypothetical tunnels through space-time that might allow shortcuts between different points in time. Some theories suggest that black holes could actually be entrances to wormholes, but there's a catch. Keeping them open requires exotic matter with negative energy, something we've never observed in nature. Could advanced alien civilizations have figured out a way to stabilize them? If so, black holes might not just be destructive voids but hidden doorways through time itself. What are wormholes? Imagine a tunnel through space and time, a shortcut that lets you travel light years in an instant. That's the concept of a wormhole, a theoretical bridge connecting two distant points in space-time. First proposed in Einstein's general relativity, Wormholes are sometimes called Einstein-Rosen bridges and are often depicted in sci-fi as portals that make interstellar travel possible. Unlike black holes, which are one-way traps, wormholes could act as two-way doors, allowing matter and even spacecraft to pass through. But here's the catch: if wormholes do exist, they are likely unstable. The moment something enters, it might collapse instantly, making travel impossible. Scientists believe that to keep a wormhole open it would require exotic matter, a form of energy that defies the laws of physics as we know them. Some theories even suggest that wormholes could connect parallel universes or different points in time, making them potential gateways not just across space but across dimensions. If we could ever stabilize one, it would revolutionize space travel forever. But do they really exist? That's where things get complicated. Are wormholes real or just theoretical? Right now, wormholes exist only in equations, not in reality. Scientists have never observed one, but the math behind them checks out. According to Einstein's general relativity, spacetime can bend and fold, meaning wormholes could be possible under the right conditions. In fact, some physicists believe that tiny wormholes might appear at the quantum level, constantly forming and vanishing within the fabric of reality. These are called quantum foam wormholes, but they are far too small for us to use. The biggest problem? Stability. Normal matter cannot hold a wormhole open, it would collapse instantly. The only way to stabilize one is through negative energy or exotic matter, something we have never found in nature. However, some advanced theoretical models suggest that naturally occurring wormholes might exist inside black holes, or even at the center of galaxies. If that's true, then maybe the universe already has built-in shortcuts, waiting to be discovered. Until we find solid proof, wormholes remain an exciting but unproven possibility, one that could change everything we know about space and time. Black holes and wormholes might sound similar, but they are completely different cosmic phenomena. A black hole is like a cosmic trap. It pulls everything in, including light, with no escape. It's formed from the collapse of a massive star, creating a region of infinite density known as a singularity. Once you cross its event horizon, you're doomed to be crushed by gravity. A wormhole, on the other hand, isn't a trap, it's a potential shortcut through space and time. Instead of pulling things in and crushing them, a wormhole, if stable, could allow matter to pass through and emerge somewhere else, possibly even in another galaxy or universe. The problem? Black holes definitely exist. We've observed them in space. But wormholes? They remain purely theoretical. Another key difference is stability. Black holes last for billions of years, but wormholes, if they exist, might collapse instantly without exotic matter to hold them open. While black holes are real and terrifying, wormholes are like a dream, one that, if proven, could change space travel forever. Could wormholes connect different universes? One of the most mind-blowing theories in modern physics suggests that wormholes might be more than just shortcuts within our universe. They could be bridges to other universes entirely. This idea is linked to the multiverse theory, which proposes that our universe is just one of many. If wormholes exist, they might not just link distant points in space but act as portals between parallel realities. Some scientists even theorize that black holes could be entrances to such wormholes. If matter falls into a black hole, instead of being crushed into a singularity, it might be transported through a wormhole and emerge in an entirely different universe, possibly as a white hole, a hypothetical object that can only expel matter. This could explain where all the lost matter inside black holes actually goes. The challenge? We have no way to test this idea yet, but if we ever find evidence that wormholes connect universes, it could mean that reality is far bigger than we ever imagined, with countless parallel worlds just a wormhole away. In theory, wormhole travel could be the ultimate breakthrough in space exploration, allowing us to bypass the limitations of light-speed travel and reach distant galaxies instantly. But the problem is, no one knows if a traversable wormhole can actually exist. Even if they do, they would likely collapse the moment anything enters them, making safe passage impossible. The key to keeping a wormhole open lies in exotic matter, a form of energy with negative mass that could counteract the wormhole's natural instability. However, exotic matter has never been observed in nature, making the whole idea purely theoretical. Another issue is where a wormhole might take you. Unlike a road with clear signs, wormholes could lead to unpredictable locations or even different time periods. Some physicists believe that an advanced alien civilization, if they exist, might have already figured out how to stabilize wormholes for travel. If we ever develop the technology to manipulate space-time, humanity could one day use wormholes as cosmic highways, revolutionizing how we explore the universe. But for now, traveling through a wormhole remains a fascinating yet unsolved mystery. What if black holes and wormholes are linked? Could black holes actually be hidden wormholes in disguise? Some scientists believe so. The idea comes from the fact that black holes warp spacetime to such an extreme degree that they might actually be tunnels leading somewhere else. Instead of being a one-way trip to destruction, a black hole could function as the entrance to a wormhole, transporting anything that falls inside to another part of the universe, or even a different universe altogether. One of the most intriguing possibilities is that the matter falling into a black hole doesn't just disappear, it could be expelled through a white hole, the theoretical opposite of a black hole. Unlike black holes, white holes don't allow anything to enter them, only to exit. This raises the possibility that black holes and white holes are two ends of the same wormhole. However, no white holes have ever been observed, and the energy needed to create a stable black hole wormhole connection is beyond anything we can currently comprehend. If black holes really do connect to wormholes, it would mean that they're not just cosmic traps but hidden gateways waiting to be unlocked. Black holes and wormholes represent the greatest mysteries of the cosmos, one a trap, the other a potential gateway. While black holes are real and terrifying, wormholes remain hypothetical, but if we can ever harness their power, they could redefine how we explore the universe. Imagine a future where spaceships no longer take centuries to reach distant stars, but instead travel through cosmic shortcuts, arriving in seconds. The biggest challenge? Science and technology aren't there yet. We don't know how to create, stabilize, or navigate wormholes, but with advancements in quantum physics and AI, what seems impossible today might become reality in the future. Perhaps the universe is already filled with natural wormholes waiting to be discovered. If we ever find one and figure out how to use it, the age of interstellar travel won't just be science fiction. So, what do you think? Could we travel through one in the future? Let me know in the comments. And if you love mind-blowing space theories, don't forget to subscribe to InnoVision Tech, hit the like button, and turn on the notification bell so you never miss an adventure.